The second paper, paper 2 of the review, is the written section. Question 1a wants us to write a balanced equation. So we have calcium chloride, CaCl2, which is aqueous, reacting with silver nitrate, AgNO3, also aqueous, forming solid precipitate of AgCl, so solid, plus calcium nitrate, CaNO3, 2, aqueous. To get this balanced, I need to put a 2 in front of the AgNO3. Now I have two nitrate groups on both sides. To get my chlorines and aluminum or silvers to balance, I need to put a 2 in front of my silver chloride. Then I have a balanced reaction. Part B says, now that you have that balanced reaction, let's calculate the number of moles of silver nitrate used in the reaction, given the volume of stuff that I have to start with. So the titration is 38.5 centimeters cubed of silver nitrate. So I'm going to start with that, 38.5 centimeters cubed. My concentration, though, is not in centimeters, it's in decimeters cubed, so I need to remember that 1 decimeter cubed is equivalent to 1,000 centimeters cubed. So my centimeters cubed are going to cancel out. Then I'm going to multiply it by the concentration, 0.100 moles over decimeters cubed. My decimeters cubed cancel out. I'm going to be left with moles, which is what I want. 3.85 times 10 to the negative 3 moles of AgNO3. I'm going to take that number into my next problem, where I'm looking for the moles of calcium chloride and then the grams of calcium chloride from the original samples. So I've got two parts here. Again, starting with my last value, 3.85 times 10 to the negative 3 moles of AgNO3. Going to multiply that by the values that I have for my balanced reaction. I have 1 mole of CaCl2 for every 2 moles of AgNO3. So my moles of AgNO3 cancel out. I'm left with moles of CaCl2, and that value is 0.001925 moles of CaCl2, which would be, in the correct number of sig figs, 1.93 times 10 to the negative 3 moles of CaCl2. I then take that number, carry it out one step further, multiply it by my molar mass of calcium chloride, which I have to look at my periodic table for. Calcium is 40.078. Chlorine, there are 2 of them, times the mass, 35.453. That gives me a sum of 110.984. So that's going to go on top. Divided by 1 mole. That gives me a value of 0.214 grams of calcium chloride. Part D says I need to calculate the percentage of calcium chloride from the original sample. So I take the value that I just determined, 0.214 grams, divided by the entire sample mass, which is at the very top in my first part of the problem, 0.265 grams. I'm going to multiply by 100 to get it into percentage form, is 80.8%.